Yeah, welcome. After learning how you draw ILD for support reaction or shear force or bending moment, now let us learn how to use the ILDs which are drawn for those functions. So here I now consider a case where a point load is on the girder. So if there is a point load on the girder, how you use the ILD for evaluating various functions like support reaction, shear force or bending moment. Okay, so to start with, let us take a case of a girder with some span. Say we have 20-meter span girder. Let a single point load, maybe of 100 kilonewton, is moving on this girder. The ends of girder is AB. Okay. Now, my intention is to find a reaction at A value. Okay. When the load is at say 5 meters. Okay. So when say for example A is 5 meters, the location of the load. So now I will place this load at 5 meters. Okay, so this is 10, say this is 5. Let us place this load here. This is 5 meters, 100 kilonewton, right? So now, as you require RA value, draw ILD for RA. Okay. So from the previous sessions, if you go through my previous lectures, I have explained how to draw ILD for reaction at A. So this is 1 unit at A, 0 at B, and the triangular shape that you observe here is the ILD for RA. So which means all these values, all these ordinate values, all these heights of ILD represent RA values for various positions of the moving load, 1 unit moving load. Okay, so that is what is the meaning of this one. Now I have 100 kilonewton load moving like this, and my question is, when this 100 kilonewton is at 5 meters, what is reaction at A? This is what my question. Okay, so what you need to do, just drop the load, position of the load onto ILD. Find this ordinate value, let it be YC. Okay, so how you find YC? It's by simple similar triangle formulation. So when you look at the two triangles, one bigger triangle and one smaller triangle here, so two similar triangles, so we'll work out that. So from similar triangles, height by base of bigger triangle, height by base of bigger triangle, height by base of smaller triangle. Okay, height by base of smaller triangle. So this will give you YC as 15 by 20. Okay, so this height of this ILD here at this point. Now the function RA value is equal to, the function value is equal to, when you have a point load, it is simply load multiplied by load value multiplied by the ordinate of ILD under the point load. Okay, got it? So RA value, if you want reaction at A, you need to multiply simply the load value multiplied by this ordinate of ILD, that means height of ILD here. So substituting the values, load given is 100 kilonewton multiplied by the ordinate that we calculated is 15 by 20. Okay, so now you can see this is 5 here. Okay, 75 kilonewton. Okay, right? So this is from the ILD. Okay, same question you can even solve it by the equilibrium concept also. When you have a simply supported beam, there is a point load 5 meters from left end, 100 kilonewton load. What is reaction at A? So you can match the solution. Okay, similarly, if I am interested in RB value, okay, let us calculate RB value for the same position of the load. Okay, so this is by using ILD. How to use ILDs? So now let us draw ILD for RB. So reaction at B values ILD you are plotting now. So this will be 1 unit here, and this will be 0 here. Join these two by straight line. So this is now influence line diagram for RB. Okay. In the similar manner, just drop the load position onto the influence line diagram. Okay. Now this will be your YC value. Okay. So calculating YC for this case again, same similar triangle concept again. So 1 unit height divided by the base is 20 is equal to, again base is 5 meter, height is YC by 5. So YC value works out to be 5 by 20. Okay. Now if I want RB value, reaction at B value I want. So I use ILD for RB. So wherever there is a point load, that point load multiplied by the corresponding ordinate value. So load value is 100. Ordinate value calculated is 5 by 20. So this 20 goes for 5 here, 25 kilonewton. Okay, so from ILDs you have calculated the reaction values, which are 75 kilonewton and 25 kilonewton. Okay, so similarly, whatever may be the position of the point load, you have to just drop that position and calculate the height of the ordinate of ILD and multiply that ordinate with the load given. That will give you reaction values. Okay, so we will continue further for the other functions like shear force and bending moment. Thank you.